Hello guys, I think we're live now. I hope everyone's doing fine today. And let's do another session of OpenGL and Qt debugging. We're not as stuck today because I did actually manage to get a triangle displaying again on the screen. But I also did a lot of work to turn that sort of triangle rendering code into a proper mesh renderer. And that's what we're going to be doing today. we're gonna be refactoring that, making sure it works, because I'm pretty sure I messed something up. But let me just set up the stream by just putting the sort of chat up. Bobby, hey Bobby, you're already here. Welcome to the stream. Just as we started, just one last bit of setting up. Turn that down a little bit. Always on top. Let me know if you can hear my voice. If the audio is too high, let me know as well. I can turn off the music a little bit. I can kind of tell it's a little bit high at the moment. There you go. Hopefully that's better. Okay. I'm using Qt6, Bobby. I'm using Qt6. So let me kind of show you what I've got here at the moment. What I did is I initially just got some code from the Qt OpenGL examples. So let me turn this up a little bit and turn this down. There you go. Now I can hear myself better. So what I did, yeah, I went to the Qt OpenGL triangle example. And I got a bunch of code from there, basically. Let's see if we can find it. So Qt OpenGL triangle example. I think it was this one here. Yeah, so I basically just copied and pasted this code into my project. Let me turn this one off. And we essentially had a triangle in the end. But then I made some changes to the code because this particular tutorial uses Qt5 in the first place. But most of the Qt classes were compatible with Qt6 here. So that was no issue. But the issue is that this is using OpenGL 2. And I had to change a bunch of stuff to OpenGL 4.2. Including sort of like shaders and how you load data into OpenGL. Which is what we got at the end of last stream, I guess. You can, if you're interested, you can see that. And then in this stream, I've basically created a class to render, arbitrary meshes. So you can provide things like your vertex meshes, your vertex data, your color data, and your UV textures. And the hope is that the renderer is just going to take in an array of those objects and then render them out using the associated shader, right? Let me just open the project first and then kind of show you. But the development is very slow. I've got to say, it's very slow because it's very error prone and I can't really debug things very much. I got to sleep, going to watch another time. Amazing. Thank you, Bobby. Have a good night, yeah? And thank you for joining. Please drop a like if you can though, before you go. I would appreciate that. Thank you. Okay. And as always, since I'm doing the debugging on this, I've put down everything that I like to see in order. So in the initialization of our renderer, we should see all of these things, like the shaders being created, the attribute locations being acquired properly, and vertex buffers being initialized, element buffers being initialized, and data passed into that, and so on and so forth. Basically the same thing. But yeah. I have a feeling that this still doesn't work, obviously, because I've changed everything. There you go, we get a black screen still. And my feeling is that unfortunately, we don't have the right context when doing all the OpenGL stuff. So let's kind of make sure that whenever we initialize the OpenGL functions in Qt, that they are kind of happening after we create the window, right? So I'm just going to put a breakpoint here and a breakpoint renderer as well in my initializer. And if I go onto my Qt abstractions where I actually define the window object, I've got an initialize function too. Or in fact, I think that happens right here, right? So let's see when these things get called, because I have a slight feeling that the context isn't being created in the right place. Because whenever you create a window, an OpenGL window in Qt, you should also set the context and then kind of initialize the OpenGL functions again. But in this case, we can see that this one gets called first, and then renderer, and then shader program. So there is no issue there. Cool. Okay, so there is no issue with the rendering order. Sorry, not the initialization order. And as an example, what we should be having is sort of this here. Let me just comment out everything so you guys can see what I should get. So I've got the code here from the previous stream without using my new rendering stuff. That was on the initialization, and now we care about the rendering. Coming out. So we should see two triangles here, because this is the data that I'm basically giving you. So I've got 3 vertices for each, a line here for each vertex. So I've got 4 vertices in general, and then I'm drawing these vertices, like this is the first triangle and this is the second triangle. So you can see that the first triangle is like the first 3 vertices, and then the second triangle is the first one and then the last 2. So we should see two triangles. That's my point. There you go. So this is what I expect to see on the, I guess, on the other one, right? But this is obviously not what we're seeing with the rendering class, because there is something going on, and I kind of need to basically debug that. So yeah. And before the stream, I actually went and debugged the entire thing, and I basically put down the things that I would like to see in order here. So there is one thing we missed, which was the OpenGL initialization, right? And we want to see the window initialization. Then we want to see the shaders initialization, and then the renderer initialization. Now, what do I mean by OpenGL initialization? All of these classes that I've created here, so I've got the rendering and the shader class somewhere. This is a different shader file. So shaders here. These classes inherit from the Q OpenGL function, OpenGL functions class, I guess, which is essentially like the way you can access OpenGL functions in Qt. So Qt provides this class called OpenGL functions, where all the member functions do something with OpenGL, right? So that's the gist here. And because I protected inherit from it, I should be able to access the OpenGL functions inside my functions, inside my my member functions. For example, if I look at get color attribute, well, in this particular case, I don't really use the OpenGL functions in the shader, because Qt provides an OpenGL shader program already in here for us, and that's like already an abstraction over the OpenGL stuff, so it's very easy to kind of create shaders and compile them. So we're not using it as much here, but if you look at the renderer, when I do an add mesh, for example, and a mesh is just a vector of data, and then the index is to draw, and then the shader program associated to it. We can see that I'm using, GL generate buffers, GL bind buffers, and all of these functions, all of these OpenGL functions that we're accessing here comes from the OpenGL functions 4.21, which makes me realize that the shaders doesn't actually match that one. There you go. So in here, what I should have had is functions 4.2 core there. And again, in here, I need to do a 4.2 core. I don't think that changes too much, basically, but it's good to have the right one in here anyway. So yeah, I mean, going back to the actual goal of today, the goal is to actually use this renderer class to render my meshes, right? And yeah, if I just comment out what we've got here, and just to remember, if I just build it and then run it again, you can see what the goal is for today. Oh, okay. So what do we have here? We've got a compilation error. Is it because we are missing, or we've forward declared the wrong thing? What is going on? So member function build error, no matching function call to unsigned int. You do gotta love the C++ errors here. Couldn't deduce template pair. Template. And all I've done here was change the kind of OpenGL function object, right? So I've got core there, and we've got the shader program, which is coming from, where is it coming from? Ah, okay, so we don't really have, oh no, we do have shaders there. I do wonder if we need this at all. Well, let's leave it there though, just in case. Member function bool. Error, no matching function for call map. Unsigned int and shader program insert brace and close list. So ID value and move shader program. Why is this not being deduced properly by C++? I don't know. So what is ID? ID shader program.get ID. And that type is unsigned integer. What are shaders? Shaders should be unsigned integer to shader program as well. And we're simply just moving that program in there. And what does insert take? Insert no type and let's look at the actual documentation on the CVP reference, as always. So map insert, position, no, we don't want a position. We just want a key value example here. Yeah, I mean, the pair should work. The pair should work fine. So I don't understand why this is not being. If I do a pair here and bring on the pair in here, I think it's the utility one, right? So include utility. Does it now turn it into a pair? No, it still doesn't. round 2. Hey Tom, how's it going? Yeah, round 2, man. So basically, we are going for round 2, yeah? I got it to work last time. Now I'm just turning everything into abstractions here, so I can do more work on top of all this shit. But I'm getting very fucked up compiler errors, as you can see. C++ doesn't necessarily give you the most friendly errors, so it's difficult to see what's going on. Class template argument deduction failed. Error, use of deleted function. Shader program. ... Why is it deleted? Good question. Shader program. So that generally means use of deleted function. There, OpenGL. Core. We are including that in there. Wolfox, hi Wolfox, welcome to another stream. Thank you for joining. Slim, yo, hey guys. Oh, got quite a lot of people now watching me, the pressure's on. Yeah, it's funny because if I do this, if I just do OpenGL functions, and then I just inherit from OpenGL functions now, and this is my own shader type, because I'm basically just abstracting the shader type. Bro, what is this junk of course supposed to do? Junk of course supposed to do. This is not a course, it's just me coding, by the way. But yeah, I mean, the series, it was supposed to be an audio visualizer in the end, but I'm kind of getting madly stuck on OpenGL. Unfortunately, that's the intention. And what we do want by the end of today is to have something like this, but drawing from my renderer class, right? That's what I'm I'm trying to do. I could slowly, I guess, you know, this is using the inline shaders from my main function here. So not necessarily my shader class, right? So this is using the straight up Qt OpenGL shaders. So I could start by swapping this shader with my shader and seeing if that's the issue. Now slowly debug what's going on. This playlist is shit, not gonna lie. It's very difficult to find a DCMA free sort of playlist that's actually good, by the way. The best ones that I found are like Lofi, but if you guys know any good ones, let me know. DCMA free. I don't want to listen to that one, that's the one I listen to all the time. Can I see more playlists? Or just, how do I do? Why is Spotify so shit? Why is this UI so bad? Like, I want to see all the playlists. Oh, there you go. Never mind. It's just me being stupid. Yeah, there you go. Let's go for chill, right? Let's go for something chill. No, is this the kind of chill I want to listen to? Probably not. Synthwave. That looks a little bit better. Right. Yeah, going back to this, let's swap this. Do you like trance music? I do like trance music, mate. So if you know a good DCMA free Spotify playlist, feel free to link it here, and I'll listen to it. But you know, I gotta make sure it says DCMA free at least, so I don't get copyright struck the next day. Yeah, so let's swap this shader with our shader, right? So we have the shader program. My shader, right? And if I'm not mistaken, this should initialize the OpenGL functions in here. Yeah. And then what I can do now, oh, where am I? I can add, I can compile my program, right? So compile program. And then I've got the shader program data. And yeah, this is another struct that I did just to represent the kind of like vertex fragment shaders, and they're just strings. Each of these should be like a file to a GLSL shader. So let's create that as well. got vertex shader equals vertex shader source. And then we've got the fragment shader equals the fragment. Yeah, these two things here, the vertex shader source and fragment shader source, are just like strings that I'm attaching to my binary. So this is GLSL for the two shaders in question. I mean, you guys saw that in the last stream as well. So let's go back, put that there. Why is this indenting so cursed? 1, 2, 3, 4. 1, 2, 3, 4. Wait, this is 3 indented, so it's like 1, 2, 3, 4. Oh, there's 4 here. Oh. Okay, no, this is just cursed. There you go. Let's do that and that now. Good. Better now. Same thing here. Good. Now it's all properly in line. Yeah, so we've got shader program data. This will compile my shaders and try to access my like vertex and color positions. So these are like the variables inside the shaders. It's going to get a pointer to those essentially. And then yeah, instead of all this thing, I'm just going to use my program, right? Instead of all the handwritten Qt OpenGL code, and this too, I guess. All of this, instead of all of this, I'm going to use it down here. Yeah, I don't really have to use it just yet. And let's also, instead of making this, let's put it here. So let's do a std unique pointer of my shader program. Dana J, yo, dude. I was hoping that you joined today because you're pretty good at debugging. Welcome to the stream. Welcome to the stream. Good evening. So we're getting somewhere now, Dana J. We got 2 triangles drawing. And now I'm just abstracting everything so I can have my own mesh class, right? So a mesh, if you guys have done graphics before, I'm going to explain again, it's just like a set of vertex data, color data, and like UV textures, as well as material and any other things to draw something on the screen. But in our case, we just have vertices, colors, and UV for now. So we're trying to draw like a box, basically. I'll be fairly happy today if we can do that by the end of the stream. So yeah, and then the box can then turn into a bar for the audio visualizer, right? One thing at a time. So std, I think I can do that, right? Let's just keep it empty. So we've got the M program. No pointer. Yeah, good. So by default is a new no pointer, and then we're going to comment that, and then we're going to say that my M program is going to be a stud make unique there. I'm going to shade a program, and then this is just going to initialize my program here. And then this basically will compile my program. It's a pointer, so we should change the syntax there. Yeah, so I mean, this is doing all that this code was doing before, essentially, but kind of modularized in my shader class, right? Now, whenever I was using mShader or mProgram, I have to also swap to my, I think it was called use, right? So this is what we had here, and then mProgram. We're going to set the matrix here as well. And that's what we had. What are we doing? Yeah, and then we got to release, I guess, or unuse. That's what I called it. So let's see if we still get the 2 triangles. And if we do, we kind of know that the shader isn't the problem in the new refactoring code. And if we don't see the triangles, we know that the shader is the problem. And unfortunately, debugging GL is kind of very, very difficult. I really, really struggle. But yeah, how are you guys doing today? How was the weekend? Did you guys manage to do anything interesting? Any coding? I don't know. Yeah, see, so the shader did not work here. So I know that, in fact, my shader program is the one that is kind of causing the problem, right? Now, why is that? I have no idea. I'm strongly thinking that is something to do with me inheriting from OpenGL functions and not OpenGL for functions, right? So if we look at my main here, I'm not sure if there's an issue, but if I look at my triangle window, which inherits from OpenGL window, and this one inherits from OpenGL 4.2 core, right? So I guess this could be the issue. Let's try and make that swap again. Okay. I mean, it doesn't build. Not necessarily aware of why it doesn't build. There will be an issue. There you go here. But we can just kind of, I guess, shaders.insert. Well, in fact, we do the ID value there, and we set it to stud move and shader program. Now, what's the issue here though? Function shader program operator cannot be dereferenced. It is a deleted function. Now, why is it a deleted function? So me inheriting this is making so me changing the base class kind of makes one of the functions deleted. I guess one of the move ones, move or copy. I don't know which one it was, can't remember very well. But let's analyze this a little bit further. Use of deleted function or const OpenGL core. What the hell? Initializing argument 2 of pair is ill-formed. That is so weird. Like, why can't I just move this? This, by the way, is just like a Qt class that will give you all the OpenGL functions. So why is it that this is immovable? That's a good question. Yeah, these are all the OpenGL functions you can have, by the way, all of them. Now let's see which particular error we had. Class template argument, use of deleted function, shader program. So the move one is implicitly deleted, right? Let's see, move Qt OpenGL functions 4.2. Yeah, I mean, I'm starting to think that we have to pass in like a pointer to the context now instead of like creating a new one in every object that I have. I'm starting to think that this is a better option than me inheriting this and doing what the Qt OpenGL docs say. In other words, I do something like I mean, first of all, I don't even need this. Do I need that? Do I need that? If I just remove it, Initialize OpenGL functions was not, yeah. We don't care about that anymore. Because all I'm doing in this class is basically just using the Qt OpenGL shader, I think it is, right? So wait, where are we? Where are we? There you go. So Qt OpenGL shader. Now, does this inherit from? Yeah, this is just a Qt object. Huh. But my question is, how does this then tell OpenGL that it should, you know, load the data and so on and so forth? Shader type is the one we're looking for. Has OpenGL shaders, add shader from source code. So let's take a look at this particular example here. QList OpenGL. So private disable copy. Ah, okay. So this disables the copy and inherits, I guess, declare private. What does this do? What does declare private do? Let's take a look, because Q declare private. Defines a D function which returns a D pointer, points to a private class object. It is internally used in Qt, so it's not documented and not supported to use this. Okay, I kind of feel like this is supposed to work by us passing the pointer to the OpenGL context, because we can see it here. Look, OpenGL program, this, right? So this here refers to the actual triangle window, which is an OpenGL context. And that's kind of what we're missing in our implementation. So this could be the issue. This could be the issue, I guess. So what I could do here is like, I guess I could... What can we do? What can we do? I guess I can pass in a pointer to the context, right? Or in fact, yeah, we can just do it here. So we can do something like Q OpenGL functions and then 4.2 core here, right? And pass in the context to it. And then when we get to the implementation of this in the CPP file, firstly, we need to change this because we do want a Q OpenGL functions to be taken in here to create our pointer. And then we set the context here. That's the only thing I can see that we're kind of missing between the previous code and now. And the previous code was work. I do wonder if the chat is kind of frozen, or if there's just no one watching, I guess. And there's only one person seeing this. Fair enough. Or if there's just no issues. Although we're coding by ourselves, this is still pretty fun. So if we do a context here, context, right? Good. So I mean, this should return the OpenGL with the context enabled. No instance of constructor OpenGL program matches the argument list. Why? Well, we did have that new OpenGL shader program. OpenGL shader program. I mean, let's try and build it. Anyway, let's just do it. Right, no matching function call to new OpenGL shader program context. How is this possible? How is this not working? Because in here we did have a shader being created there. And this is okay, it's a Qt object and not a freaking not a shader, not an OpenGL object, a function object, is it? That's what we're about to find out. OpenGL shader program. Let's look at the constructor of it and figure out. Yeah, it's a Qt object. It's a Qt object. Now, what does the parent do? The program constructs a new shader program and attaches it to the parent. The program will be invalid until add shader is. The shader program will be associated with the current OpenGL context. So whatever is the current OpenGL context, that's what we kind of have, right? Huh. So basically, as long as we have a valid OpenGL context here, it should work. Let's change that to a Qt object, shall we? But this is just for memory management inside Qt. So it doesn't really matter much here what we have. Qt object. Just a forward declaration for the Qt object class. Let's see if we can get further in the compilation, and then we're going to get some errors in the main function, I think. There you go. Yeah, that does mean that the renderer is going to need some kind of OpenGL functions. Can I say kind of this? Yeah, does it work? Is it a Qt object? Seems to be a Qt object. Nice. Not a Qt object. It's not a problem though. We can kind of make this into a Qt object. What is this issue? No instance of constructor shader program matches the argument list. Argument renderer. Let's see if we can just do a simple dynamic cast for now. What is the issue? Gosh. Look at this required from here. Like, what is the actual issue though? I have to scroll down so much to actually just get a valid kind of error. Maybe this isn't the answer. Okay. Yeah, my documentation kind of makes it seem like we don't need to pass in the Q object because it binds it to the current context anyway. We get a little bit more friendly now. So what's the issue here? Yeah, let's just create a shader program, rebuild. Let's build now, but we're still going to get the black screen because we haven't really done anything meaningful. Oh gosh, oh gosh, oh gosh. So it binds it to the current one. So right. So how do I know if it's if the current context, the OpenGL context, is set? By seeing whenever the context set function gets called, right? That's one way to do it. The set context create. So this one is the one that runs. So we're expecting this breakpoint to hit before the creation of the shader. Let's see if we do get that. Yeah, we get that. As expected, right? Create the context, initialize the GL functions, and then we create the shader itself. But it still doesn't draw. It still doesn't freaking draw. Even though none of these functions return an error. None of them. So we have these exact lines in here. So we have add shader from source, vertex shader, gives me the data vertex shader, right? And I'm going to put a breakpoint there so we can debug and see what's going on. And in the meantime, I'm also going to add shader from source. Just want to see what this kind of tells us. So this function is intended to be a shortcut for quick adding vertex and fragment shaders to a shader program without creating an instance of Q OpenGL shader first. It doesn't say what it returns and what it doesn't return. Or false otherwise. Ownership of the shader object remains with the caller. It will not be deleted when this OpenGL finishes creating the shader. This allows the caller to add the same shader to multiple shader programs. Cool. Cool. Yeah, we definitely are using this one. And we're not really getting any errors. I mean, if I put it through it, so you can see I'm creating the shader program here and compiling the shader. And we're adding the vertex shader here. The vertex shader data is all of this. And it seems to be the correct one, I guess. Right? Let's see. Yeah. So it does add it correctly because we're not returning false there. We are able to link it at least. And we get all of the vertex attributes there. So contain value 0. I feel like I know this song. Relic song. Oh, it sounds like Kiss from the Rose by Seal. Very similar. It's like an 8-bit version of that. Anyway, yeah, when we compile the program, and that's what we had here. Up to this stage, this is exactly what we've got. Yeah, if I look at the program, you can see that I've got the vertex Oops. Vertex attribute, color attribute, UV attribute, matrix uniform is -1 though. That is worrying. Why is he returning me -1? Could that be the fucking issue? Could that be the issue, guys? Could that be the issue? Let's see. Let's see. Auto const. Maybe matrix. Uniform. Wait a second, so I do get the matrix uniform there. Okay, that's the uniform location matrix. What does that return? An integer. We better be using this. We better be using this. Matrix uniform. Let's put it up here because I also want to do an assertion. Yeah. Q assert. And the matrix uniform is in -1 or something. Right? Because it returns an integer. Yeah. Right. So when I set the matrix, what was it doing? Yeah, that could be the issue, boys. Because this, if you don't set, or if you set something in GLSL that you think you've set, but you haven't actually set, it may come out as 0. So my matrix transform was just zeros, right? Which means it's shaping all my vertices into just like a 0, I guess. Just times in all of them to 0. So at 1 point. Now, do I think that this solved it? I don't know. We'll see now. We will see now. Okay. Okay, a little bit better. What's the assert? So again, matrix uniform returns -1. What? No, it doesn't. It's just me being absolutely stupid there. I gotta say that I've been really sort of like enjoying these streams in the past few weeks. I started doing this maybe, I think it was like 2 weeks ago, where I started streaming a lot more than I used to before, because there's a way of, I guess, coding with people watching you, and it's not as scary as it sounds. I mean, if you get stuck, like I do all the time, it's not too bad. You've got people to help you, but also it's good for me to kind of talk through what I'm basically thinking about, like how I plan things, so people can see, you know, the truth of programming. It's not always kind of like really easy as people make out to be. Sometimes you're trying to do OpenGL and you get a black screen for 3 or 4 hours straight away and you can't solve it, and that's fine, you know, just gotta understand that. But yeah. Boom, boom. Now that didn't work either. We'll see why. Okay, so we get the shaders, we get fragment shaders, compiler, link the shaders, get the matrix uniform. It turns out to be 0, which makes sense. Okay, and then return true here. So we've successfully compiled the program, and we got something that makes kind of sense now. So the matrix uniform is a valid buffer ID. Cool. And we generate the buffers here, the vertex buffer. Okay, and we send the data of the vertices. send the elements, so each indices we're going to draw. So we create the vertex attribute object, the thing that remembers how the data is laid out in the buffers, because you've got to tell OpenGL what the data actually means once you've sent it up. And then we bind the vertex buffer to say, you know, the data layout. What do we have here? We've got the positions, fine. We've got the colors, fine as well. And the position between, you know, the current position and the next one is about 8 times the size of float. That's because we've got 8 elements in between, you know, each position. So, you know, each vertex has 8 elements in it because I've got RGB, XYZ, and UV. So that's 8 overall. So you can see the, you know, the stride here. So the difference between them should be 8 times the size of float. So that kind of makes sense as well. And I know that this is working, in fact, because, you know, it was drawing before. So what is this now? So this is the OpenGL render now function. I kind of want to see what happens in the actual rendering, right? So if I just put a breakpoint there, let's see what's going on. So I get the retina display, the scale, I do the viewport, and I use my program. So what does use program do? It binds my program, which is kind of, is that what I wanted? Yeah, it is the bind function. So at this point, I know that I've bound my stuff to it. So the matrix in this case, is it 0? It can't be, right? Yeah, it's not a 0 matrix. I can see that it has some elements, some values to it. Now, is this actually setting the matrix? So I set the matrix uniform to matrix. Does that return anything that I can use? No. Yeah, this is just binding the buffers, making sure that they are kind of valid, I guess, in this context, in this drawing request. Then I get my vertex arrays and enable my position and color ones. And I draw the elements. And then I unuse the program here, so unbind. But this is still not working, is it? This is still drawing me a black screen. And the issues with the shader, still. Now you may ask, why is it the shader? Well, because when I was kind of using the older shader, so the inline shader that I've got here, so I was doing in program dot, is it release or something? And then in here it was something like bind, and then I had this instead. And then I had this and going up to where we had everything, so like this, all this stuff here. Yeah, so when we have the when we inline all the OpenGL shader stuff, it works. So there is something wrong with the shader and I can't really figure out what. Let's see if we get the triangles now. I mean, the only thing we don't have is this pointer here. This pointer is not showing in our like creation. It's just not there. There you go. So this works, but our shader doesn't. Now, if I remove this, does it work? Does it work? I mean, this is a memory leak because Qt doesn't get rid of I guess this object in the end, but up until then, does it work? That's my question. I want to know if it tries to get the context from the object that we pass into it. Yeah, I mean, it makes no difference. Cool. Now, how do we solve this? Well, we solve this by making things a little bit, change it slightly, but not as much. So what can we make a slight change here? Well, I could kind of expose this, right? So instead of having this here now, I can just expose that pointer itself somehow. So Q, OpenGL shader program. I can see which bits are the bits that are breaking the entire thing, right? Just for testing. To do remove testing code. OpenGL shader program pointer. And then on the CPP file, I can kind of expose that function. See, I can implement now. C program get shader here. What's the issue? Declaration is incompatible with OpenGL shader program pointer. OpenGL shader program pointer. Declaration is incompatible with what? Oh yeah, it has to be a reference, because obviously you can't copy a unique pointer, so you either pass it, you send a reference, or you kind of move it. We're just going to return the shader here. Yeah, let's return that shader. Why did I do that? Well, because I can come in here and kind of slightly change this. So again, I'm going to make my shader sort of like member variable here into a unique pointer of the program type, which is going to bring a lot of red lines, but that's fine. I'm going to create it here, and instead of kind of like using the functions that I've created to abstract the entire shader, I'm going to change, you know, very few of them to use the shader that's returned from my shader, if it makes sense. I know it sounds very confusing, but I'm just going to use the underlying OpenGL shader from my shader class to slightly change some of the behavior and then see where it breaks. Essentially, that's what I'm trying to do. When I have no idea what's going wrong and debugging can't really help me, that's the only way to do it, really. So I don't need this. Let's just move the compilation to our shader here, shall we? Which means we can now comment that out, but then we're gonna still use these functions here, where we're gonna go for the get shader, and here as well we're gonna use the get shader function. just like that. And if this doesn't work, we kind of know that the problem is in the compilation, right? It becomes very easy to my ass kind of hurts from sitting down all day in front of my computer, and I've done like virtually zero exercise today, so I definitely need to improve tomorrow and actually get out of home. Do you guys do anything when you're, when you're at home? Do you guys exercise? What do you guys usually do? Okay, so this still works. So I know for a fact that the compile program here is not the issue, right? This is not the issue. Now I'm going to comment all of these out here, the position attributes and whatnot. In fact, I'm going to comment this one out, or one at a time actually. Let's just do the position one first, right? So commenting the position one makes it so I have to, instead of using this, whenever we use it, we have to get the shader one. So is it M shader? M program, sorry. And we get the vertex attribute there. And that should be an integer? Yeah, that should be an integer. Right? Yeah, that is an integer. And the same thing for here. M program.get vertex attribute. Okay. And again in here, we have this one. M program.get vertex attribute. This sounds like Pokemon music. Is this what it is? Kind of ending theme, yeah. I am really scared of getting a DCMA strike now, so I'm gonna switch the playlist. Sounds too copyrighted for me. Yeah. Tomorrow, I think I'm going to continue with the Rust streams. This still works, so I know for a fact that the vertex attribute still works fine, right? So let's now move on to the color one and do step by step, and then eventually it will break, and then we'll figure out exactly what's breaking the whole code. So yeah. Alright, so this is the color one. So let's firstly begin by commenting this out. And in here we comment it out as well. So we get a color attribute there, and then there's going to be another one here somewhere. Yeah, I definitely feel like these C++ streams are very boring, very, very boring. People hardly stick around for more than kind of 50 minutes, just because of the nature of the code, I guess. I mean, it's one of those things where if you get stuck, you're going to be on it for at least an hour. So yeah, it's not enjoyable for people to watch it, but don't say that, Slim. But it's true though. You know, the data doesn't lie. I can see it on the channel whenever I do like something, and maybe not the videos. The videos are actually quite good, like the C++ videos. But overall, it's sick. Yeah, I mean, when it works, it's sick. But you know, when you're stuck, it's kind of, yeah, man. People don't tend to stick around. Yeah, but like Rust streams compared to C++ streams on this channel, they are, I guess, more interactive, I would say. Like, people stick around a little bit more. All right, so what do we have? Yeah, so the color one still works in our class as well. We still get that. Yeah, so now what can we do now? So we create, compile program there. Let's change the uniform. I guess that's the only remaining thing, right? Let's come into OWL. What I will say is that most people actually follow the channel, I guess, to subscribe because of the C++ content that I've done in the past, though. Not so much now, because I think I've gotten a lot of like the Rust following as well recently from the streams. So I think the channel went from something like, yeah, it was like 350 subscribers to 500 in like a month. So, and this is when I was doing kind of like streams very often for the past like 2 or 3 weeks. So I can't complain, you know. Both C++ and Rust are kind of interesting to the channel in the end anyway. Right, so this is, we commented out the matrix uniform, so that we have to use it kind of here now. So m program .get shader get matrix uniform. You don't drink coffee, but I did drink coffee, dude. I drink coffee like maybe twice a day, but not at 10 though. I mean, if you're drinking coffee at 10 p.m, I'd recommend not to do that, because then you definitely can't sleep until like 3 or 4 a.m. Stays in your body for like, I think it's something like 6 to 8 hours, right? That's what I saw online. So I tend not to drink it because I have work in the morning, so I want to get some good sleep. But yeah. Matrix stuff is still working as well, so that's good news. Good. So what can we change? What else can we change? What about you? How many coffees you drink a day, Slim? I'm gonna guess it's more than one. I mean, two, yeah, 2. I feel like, yeah, 2 is like the average, innit, for a person. But I want to reduce, yeah. I've been trying to reduce like maybe once a day now, especially like without a lot of sugar. So I bought these kind of like sweeteners for coffee, because I used to have like, dude, like 3 or 4 sugars each coffee. It was bad. It was very bad. Like, wake up straight away, have a coffee with 4 sugars. That was my routine for you, man. Alright, so what's going on? So we've got program there. So now let's change the release to just like unuse. Let's see if that makes any difference. Like, slowly gonna switch this entire implementation to my own shader class, but do it very slowly, because if I do it too quickly, I'm gonna break too many things and not know what actually caused it. So what is it that you do, man? Do you just live in London? Are you a student, or do you work in London as well? I'm guessing that you do coding, right? You're a programmer of some sort, like a software engineer or a developer. So yeah, your unuse still works. So let's actually use it here. There's a double. One thing that I'm kind of disliking a little bit about the C++ ecosystem today is that IntelliSense is kind of like broken. Not broken, but it takes a long time, I guess, to reflect the changes that you've made, at least for me on VS Code, which is kind of tends to be the same on NVim as well. Okay, so that still works. That's good. Good news. Good news. Now let's try, instead of setting the uniform manually here with the pointer, we're just going to say set matrix, right? You consider NeoVim? Yeah, I use NeoVim whenever I do something on the Raspberry Pi. Usually, sometimes I feel like coding on the Raspberry Pi. I've got like an NVim set up in a... I've got a video on the channel actually with my setup if you want to check it out. It's somewhere, maybe like 6 months ago. But yeah, NeoVim is quite good. It's quite lightweight compared to VS Code. However, I do prefer VS Code just to the like generous number of extensions that you can get, not just for C++ and for any language out there, which you can kind of get in a NeoVim as well, but it's much easier to install on VS Code and there's no messing up with configuration files. So it's not a bad idea to use nowadays, in my opinion. I know there's people who dislike it very much, but you know, it doesn't really matter what tool you use as long as you're using it well, I guess. That's what matters, right? So yeah, this still works as well. So where else are we using getShader? Yeah, we're not using getShader anymore. Okay, so you got used and program use shaders. I've got on use, and I think that's everything that we needed to do here. Right. So have I fixed it somehow? I've not changed much anyway. This is so confusing, man. Very, very confusing. Want to make it a little bit more cleaner, let's just change all of the shit we had. This is what for? This is the colors. Yeah, we don't need that anymore. Yeah, what do you guys use? Do you use VS Code as well, NeoVim, or something a bit more advanced, I guess, or not advanced, but more beefy like Visual Studio or CLion? I used to be a massive CLion fan, actually. I used to love CLion. Not a bad idea. It was like before Visual Studio Code implemented like the whole CMake ecosystem in it. CLion used to be like the IDE to do that. So yeah. Okay, cool. So that also works. Yeah, that's definitely cool, but like, why is it working? It wasn't working before, now it is. So So I've got shader program, we compile that. Have we changed anything in the initializer? I don't think I did, right? Yeah, not at all, not at all. Still the same. So the problem must really be in the renderer. It must be, like, vertex shader. Okay, bro, see you tomorrow. See you, man. Thank you for joining the stream, though. Yeah, you too, man. Have a good night. Have a good night. Okay. And define reference to vtable renderer. Oh. What do you mean? What do you mean? And define reference to. Let's remove that. I have no idea what I did, but it fixed it. No freaking clue. No freaking clue. But it's working now, and I have no idea why. No idea why. Yeah. And now let's try and make a cube, right? So let's draw it out first. Let's draw it out first. We've got Zerno somewhere. So what we want to do is we want to have like a little cube, right? So let's see if I can get this first. So you want to have that, something like this, right? Now, is this going to be difficult? Probably is. Probably is a little bit. Yeah, so let's think about one face. One of the faces of this. So as you guys know, everything in OpenGL is sort of drawn in kind of triangles, right? By default, it's all drawn in triangles. You can do, I mean, fundamentally it's all triangles anyway, even if you mess up with the geometry shader. So one triangle that we do have is kind of like this one here. Can we do dotted lines on this? Yeah, we've got like this first triangle, right? So this is the one that we can kind of do here. Which kind of, yeah, let's just say that this is like 0, 0, right? The origin 0, 0. This is 0.5, 0, and this is 0 and 0.5, right? I hope you guys can kind of see my handwriting. And then we can also do the second face, right, for the first plane here, which will be this one here. That one is actually very easy as well. This is 0.5, 0.5. And let's call this one the first one, the second one, the third one, and the fourth index. Right? So if we had this in an array, this is what we would have. Do we have text here? We do, right? Text, yeah. So this array, I mean, assuming that I can represent these vertices in my mesh, right? I want to draw 1, 2, and 3. And then my second triangle would be 2, 3, and 4. 2, 3, and 4, right? Kind of like that. Or if you want to do it like the proper winding, so the same sort of like rotation, so like 1, 2, 3. It'll be 2, 3, 2, 4, 3. So 2, 4, 3. Let's try and draw this one, right? If we can do this, we can do the rest. It's actually very simple from here, now that we've got something that, you know, truly works. So we've got all my meshes here. So what I wanted to do is I wanted to kind of represent this a little bit different. I think, yeah, the first one, what was it? 0 and 0. So we've got 0, x, y will be 0 as well here. Z is always going to be 0 in this particular case. This is just, let's say this is on the XY plane, right? So Z is equal 0 here. The second one, we don't really care about the color for now. Hey, what are you working on? Hey, Adomas, I'm trying to basically create a little engine for my audio visualizer. Right now, I can only draw triangles on the screen, and I'm trying to draw a cube with OpenGL. And if this works, you can see the result in a bit, but I just spend like maybe this stream and last stream just debugging an issue that I was stuck on, and only now I fixed it, so I can draw things on the screen with OpenGL. But yeah, I mean, in the end, he'll be an audio visualizer, but today was just for refactoring some code and creating a mesh renderer with OpenGL. And we've finally got a mesh renderer, which does vertexes and colors for now. Doesn't do textures yet, but we're getting there. So I've got this first vertex. I want to do the second vertex, which is 0.5. So let's do a 0.5 and 0 here. Let's put, yeah, the color will be the same for now. I don't really care. And then the last one was 0 and 0.5, right? So the third one, so 0 here and 0.5. Although, yeah. Yeah, this is not centered on the origin, by the way, so it's gonna rotate with my screen. That's fine. So 0, 0.5, 0, 0, and we need another vertex, right? As we said, we want to draw this one too, which will give us two triangles, or in other words, these two triangles together here, which is going to form, for what you will use Qt. So Qt does the window, so I have to create an OpenGL window and an OpenGL context, and Qt handles all of that. Qt has like OpenGL bindings exposed, so I can actually use OpenGL with Qt, as opposed to a GLFW or something like LUT, which is what I tried before actually, but didn't really work very well with my my setup here, because I've got some static analyzers and memory sanitizers that are very much complaining a lot when I run GLFW and not Qt. Yeah, the last one that we had was 0.5 and 0.5, right? Let's set it to the same color as my first one, which was 0 there and 1 there. So my indexes will be 0, 1, and 2, and then 1, 3, and 2. 0, 1, and 2, 1, 3, and 2. Okay. So mesh data is equals to that. Okay, cool. So if we compile this, and if we run this, it should give us that little face that we just worked out here. Is it Qt6? Yeah, it's Qt6, and I'm actually using Conan to pull all of that. So I'm not actually like putting the files on my computer myself. I'm getting Conan to build all of my dependencies here. You should probably check out the very first stream if you want to learn how to do that. I'm not sure if you know about Conan, but yeah, it's a very easy way to include libraries. Very, very easy indeed. So there you go, that's Qt initializing. And we've got that little square that we spoke about, right? So it's rotating around this axis here because I've got like a rotation matrix going on, which is just rotating every odd seconds or something, right? Now, it would be cool to do this other one here, right? So we've got yeah, we've got that. We want to do the other face. Let's work out the other face, right? So we want to do this face here, basically, of that. Now, what we do already have is we've got 2 vertices, and that's 2 and 4, right? So, in fact, let me match it with the code. This should be this should be the index 0. This should be the index 2. This should be the index 3, and this is the index 4. Let's put it here. Sorry about my handwriting, I'm using a mouse. So we've already got 2 and 4. What we do need is these other 2 here, right? So let's say, yeah, this is Z kind of like 0.5, right? So this is actually 0.5, 0, but also 0.5 there in Z, right? And these are all like dot 0 in the Z axis, right? So all of these are like Z axis equals 0. But we do want to put this extra one here and this extra one there. Is it alive? It is alive now. It is alive, yeah. With there you go. I'm just drawing the cube. Not so boring. It took us a while, but we finally figured out what the issue was, and it was something to do with my shader. I think it was the uniform not being set properly, the matrix uniform. So you see, without debugging in OpenGL, it's very difficult to actually figure out what the issue is, and you may spend hours, like I just did, just to figure out one minor issue. But now, yeah, we've got essentially a class that renders meshes. As long as you've got the meshes defined, you can render it. That's all I wanted to do. Wow, impressive. It's just a square for now, just a square. It'll be more impressive once I do an actual, I guess, a cube, right? That would be way more impressive. But yeah, let's add these 2. So this is also 0.5. Okay. So yeah, let's add those 2 in our renderer class. Sorry, in our renderer. So I need 2 more, right? So I need, what was it, 0.5, 0, 0.5, 0, 0.5 here. And this is also going to be 0.5 and 0.5, 0.5. Looks like the hard part is behind now. Yeah, the hard part is definitely behind. Getting the very first few things to render. I will say that whenever, if I do decide to do textures for some reason to make it look nice and prettier, that will also be a hard part, by the way, because that involves me messing around with the shaders and including more data to my UV stuff. And yeah, but that's, you know, for a different day. So just to make sure, so vertex 0, this is vertex 1, this is vertex 2, this is vertex 3, and this is vertex 4, and this is vertex 5, right? So right now I'm using, let's call this vertex 02. This should have been like 1 here. This is vertex 1, this is vertex 2, 0, 1, 2, this is vertex 3, this is vertex 4, and this is vertex 5 here, right? So what I want to do now is I want to do vertex 1, 4, and 3, all right? Vertex 1, right? 1, 4, and 3. So that will do, you know, these ones here. As you can see, that's terrible handwriting. I'm sorry about that. And after that, I want to do 4, 5, and 3, right? So I want to do 4, 5, and 3. Color-wise, I don't really know. Let's see what color we can give them. Well, they're both the same color, so let's just compile and see what happens. I could have also programmatically done this, would have probably been simpler, but I just want to show you guys how the meshes are kind of drawn in this. So yeah, generally you have like an array of vertex or mesh data, and that includes positions, colors of each vertex, normals of each vertex, and kind of UV textures. So like which positions on the image it will be. And then you have the indices, so like the actual, like in which order should you draw the triangles. Like this is one triangle that's going to be drawn in, this is another triangle, this is another triangle, another triangle, and so on and so forth. So I'm just showing that manual work so you can appreciate how much work these like game engines do, I guess, when it comes to all of this. There you go. So we've got part of a cube, right? So that's good. That's good. Now we just got to do the bottom, I guess. Yeah, no. Let's see which one we're gonna do. So you see, this is red to blue. I'm trying to see like what color to put it to make it a bit more obvious. So the last two, the one that's on the bottom we want to put to green. The one that's on the bottom we want to put to green. Okay, so RG. And then this one here, we want to put it to red. Okay, yeah. Bloody internet kinda killed me. Oh, did you miss all the boring work? Now we're drawing a cube. Now we're drawing a cube. See, now it's more interesting when people actually realize that we're getting somewhere and not we're just stuck somewhere. Do you know what I mean? Like, we're not just stuck for hours. Is it working now? Yeah, we got a mesh renderer, Tom. So a mesh renderer that kind of does all the vertices that we ask it to. So we're doing a cube now. We've just done two faces, like this one here and this one here. I'm working out which ones we need. Now we need the same on the other side. So we've got these two already. So what we need is like this one and this one, right? I'm missing the saucy stuff. Yeah, you're missing the saucy stuff, dude. This is the saucy stuff right here. So like, the goal for today is just to do the fucking cube and then I'll go to bed. But yeah. Right. We can do a Nintendo 64 logo in the future. So yeah, I mean, we've got these two. Now we need to add these two here. So that one and that one. Now these are both on Z equals 0.5 as well. But they have the same X and Y position as my 0 and 3, right? So my 0 and 3 are the ones that I need to copy. So this one here, 0 and which one was it? And the third one. Wait, what? 0, 1, 2. Yeah. 0, 1, 2. This one here. But I kind of just say 0.5 there and 0.5 there. So this should work. Now, which color do I want to put? I have no idea. We just see how it goes. But basically, what do I want? I want 4 and 5. Let's call this one 6. Which one did I add first? 0, 0. So yeah, 0, 0. This one's my 6th one. And this is my 7th one. So I want to do 4, 7, and 6. So 4, 7, and 6. By the way, this is it. 6, 7. So 4, 7, and 6, and then maybe 4, 5, 7. Yeah. 4, 5, 7. Let's build it. And by the way, this references the indices that I'm drawing here, and each 3 indices forms a triangle, and that's how OpenGL draws things. If you guys are unaware, it draws triangles, and it didn't work. Why? Why did it not work? So 0.5. Did I even build? Did I even build? Don't believe that I built. So let's see now. Yay, kind of. So what do we have here? We've got the wait, which side is it supposed to be? So it's not drawing one of them. So I've got 4, 5, 7, 4, 5, 7. Yeah, what the fuck did I do? So I'm drawing the same triangle twice. So I've got 4, 5, 7, and 4. It should be 4, 6. There you go, 4, 6, 5. Oops, 4, 6, 5. There you go. And we should, in theory, have everything to draw, I guess, the rest of them, because we've got all the vertices necessary, right? We've got 7 vertices overall. 1, 2, 3, 4. Sorry, 8 vertices. So all we've got to do is like draw this bit and the bottom bit, and that should be our cube for today. Something is gone wrong. What has gone wrong? So it's like we're missing a triangle. Wait, so what did I do? So I've got 4, 6, 7 there, and then 4, 5, 7 there. So 6 should be 0, 0, 0.5, right? Let me just make sure that the code is right. So my 6 for 1 should be 0, 0, 0.5. Good. And my 7th should be 0, 0.5, 0.5. 7 should be 0, 0.5, 0.5. That's correct. Yeah. 4 should be 0.5, 0, 0.5. So 4 should be 0.5, 0, 0.5. That's correct. And 5 for me should be 0.5, 0.5, or 0.5. Yeah. That sounds good as well. So why is this missing? I wish I could pause this, you know. This is annoying, this rotation, but I'm not getting rid of it. So it's drawing. It's as if it did kind of this. It's like there and there. Do you know what I mean? Which may be what it did, really. So 1, 2, 3. Yeah, so we've got 4, 6, 7, right? Let's see, 4, 6, 7, and 4, 5, 7. Yeah, that's what was wrong, I think. It may make it easy for you guys to see if I do this as well. So each 3 indices is a triangle that we're drawing. So like this is face 1, this is face 2, and so on and so forth. And it still doesn't work. Still didn't work. 4, 6, 7. So we've got 4 here. 4. Wait. Which face am I even drawing? 1, 2, 1. Yeah, so each of these 2 is part of a face. So each triangle is like half of a square, basically. You can kind of see here. So this is like one triangle that I'm drawing. So this is face 1. 4, 6, 7. 4, 6, 7 is doing that there. And 4, 5, 7. 4, 5, 7 should be doing that. So that is a whole one. But I've only got phase 2. But I've only got 3 faces. Phase 3, and this is phase 3. Yeah, the last one is fucked up somehow. And I guess I'll figure out why. Oh yeah, there's a syntax error there. Ooh. Yeah, generating this programmatically would be so much easier. There you go. Now it's correct. Cool, cool. Yeah, so in theory, we've got all of the shit now to draw it out. So we've done, I guess, these ones. So this face here, like this one, and the one on the back as well. Now we need to do this one, which would be 0 to 6. Let's do another one. So 0 to 6. And then we've got 0, 2 and 6, and then we've got 2, 6 and 7. If we build it now, we should have like all the sides done. We're only missing the top and the bottom. Right? Yeah, we've got all the sides, right? I can't really tell. Can't really tell. So let's see if I can rotate from the other side, like top and bottom rotation now. It would be nice if I could do like a mouse rotation, but that's, you know, I'm gonna leave that for another day. Definitely don't have time to do this before I go to bed. But what I do have time to do is basically come in my rendering function and setting my rotation here to 0.0f there, and then removing one of the zeros there, and do a Y rotation instead, so you guys can see it rotating the other way around. Hopefully, right? If this is what it means. Let's have a look. We can see the documentation of it. Q matrix 4x4. Rotate. There you go. So angle, float X, float Y. Yeah. Wait, no, this is wrong then. So it was what we had before. Huh? Float X, float Y. Angle, X and Y rotation, float 0. What if we do this? What happens? We want the one with 4 things in it. It's just nothing happens. Yeah, we messed up. So this is getting the angle 0, 1, 0. 0, 1, 0. I think we might want to change these ones then. This is how much you want to kind of rotate on that axis. X, Y, Z. Yeah, it must be that one. Angle, X, Y, Z. It's this one here, definitely. This is an overload function. Multiplies the matrix by another that rotates the coordinates through angle degrees about the vector X, Y, Z. Yeah, this is... There you go. So I'm rotating about the X-axis now. So let's see. That makes more sense. There you go. Yeah, see, we're still missing one of the sides. Still missing that side. 1, 2, 3. So yeah, we've not got all of them. Are we already drawing this to somewhere? 0, 2, and 6. 0, 2, 6. So 0, 2, and 6. 0, 6, and 2. These are those ones in there. Yeah, let me see what didn't work here. So 0, 2, 6. 0, 2, 6 should in theory do these here on that side. 1, 4, 3, and 5. 1, 4, 3, and 5. That's my face here. Face 1 is this one here. 0, 1, 2, and 3. 0, 1, 2, and 3. 1, 4, 3, and 5. And then we've got 4, 6, 7, 4, 6. No. Yeah. We've got 4, 5, 6, and 7. Yeah. So we've got 4, 5, 6, and 7. That's that one there. 1, 4, 3, 5. And then this one should be these two. So 0, 2, 6, 7. So 0, 2, 6, and 7. Why is this not working? Why? Yeah, we're still nothing on that side there. Is it because we literally can't see it, I guess? Like it's perpendicular. So let's translate everything to minus 0.5. Okay, yeah, maybe we can do that. I'm gonna move the cube a little bit so we can kind of see it a little bit better. And the way I do that is by moving the matrix here in the render function. If I can find that now, Jesus Christ. Yeah, in the render function I can do a translation -2. So what does this do? It does -2. Okay, let's try that. There you go. Yeah, we just couldn't see it before because it was right on our camera, if it makes sense, and this line is like not thick at all, so that's why we couldn't see it. But now we've got the whole cube. And okay, so let's see what we can actually do. I kind of just want to rotate this on. Can you stop running, please? 0.5. Yeah, let's do like a minus 0.5, 2.5, sorry, 0.25. So we get the cube actually rotating by the center of itself. This is just a little hack while we don't have the mouse, so we can see the entire thing. There you go. Nope. So it's still rotating by by the axis there, I guess. That's okay. We leave it as it is. Let's just do the, I guess, the other stuff, right? Yeah. Let's do the top and the bottom. Should be very easy now though. So we've got 7523. So 7523 is what we need to do. Where's our main program? So let's do phase 5. So what do we want? 273, 273, phase 5, and then we also want 357. And on the bottom we want 0, 6 and 1, or 0, 1, 6. Phase 5, let's say phase 5. It should be phase 6. 0, 1, 6, and then we want 1, 4, and 6, right? Very easy. And that should be the whole cube for tonight, guys. And I hope this finishes the stream quite on a good note, because God's sake, we got stuck for how many days was it? It was 2 hours on the Saturday. And I think it was another 2 hours on Friday as well, or Thursday. Just very silly OpenGL stuff. But since then, yeah, good night. Congrats on your progress so far. Yeah, man, we're getting there. Let's see if it worked though before I finish the stream. That's the issue. But yeah, from then we actually, there you go, a full-on cube now. From then we actually made a mesh renderer. You can see that there is some sort of like Z buffering issue there. Like it's rendering the back ones first, and you know that's not a bug. There's a way to solve that in OpenGL. It's just to enable the depth buffer, I guess. We can do that next stream though. I was expecting something more simple like a view emitter. What is a view emitter? Let me Google that because I don't even know what that is, dude. But you know, a cube is simple enough, right? It doesn't get any Oh, a view emitter. Okay, I see. Nah. Not as simple as that. A little bit more difficult. But yeah, next stream is actually to, I guess, create some actual bars that can like go up and down depending on the frequency, and we can start working with the audio as well. Because like the idea of this whole project is that I read the audio in, analyze the bits of audio, and then show the frequencies on bars. And yeah, I mean, we're not really far from that, to be honest. I mean, the hardest part is probably the OpenGL and the audio. The audio is a little bit easier because Qt provides all the audio stuff for us, so I know it's going to be quite easy. But yeah, guys, thank you for sticking around, and yeah, hope you learned something. And that's it. Good night. Bye bye.